In this video, I want to start talking about partial derivatives, and I want to do that by first talking about derivatives of functions of one real variable. So here is an example function. The sketch will be like that. And the question that we're concerned with is if we are at a particular point, let's say x0, if we change x0 a little bit, how much is y going to change? So here, for example, if we change x0 by this much, then y is going to change by this much, right? So the difference between this and this, all right? So now, usually what we say is that we're going to change x0 by h. So this is going to be h. And what we're interested in is essentially, well, if we change x0 by h, how much is y going to change? So essentially, how much is this vertical difference between this y and this y? Okay? So let's just write this down. So we're interested in essentially f x plus h minus f of x. And here, well, like obviously kind of the larger the h going to be, the larger is this difference. So what we really want is we want f of x plus h minus f of x divided by h. So that, you know, if h is larger by a factor of 2, obviously, like this is going to be larger, and usually, and we don't want to take that into account. We essentially want to say, okay, like, how many times larger is the difference in y going to be compared to the difference in x? And as you saw in calculus, and as you can see here actually, well, if h is really, really small, what you're really doing when you're computing this is you're computing the slope of the tangent here to the graph. Okay? So how do we do it formally? Well, we say we'll take the limit as h goes to 0 of this thing, and that's just going to be defined as the derivative. Now, to get back to our original question, well, you change x by a little bit, how much is y going to change? Well, the answer is, if you just kind of ignore the limit here and say, well, like, h is small enough, what you're going to say is, well, f x plus h minus f of x is going to be approximately equal to h times f prime of x. So you just move the h here, you kind of ignore the limit because you say that the h is going to be small enough. And the answer is going to be, well, you change x by h, the y is going to change by this much, where this is the derivative. Okay? And obviously, this is going to depend on x. So let's say that x0 here is equal to, you know, let's say 2, right? So we know, of course, and you can prove it using this definition, that f prime of x is equal to 2x over here. So if x0 equals 2, then what you can do is we can say, so f of x0 plus h minus f of x0 is equal to h times 2x0. And then you can just substitute 2 and you'll get an estimate for how large this difference is in those terms. Okay? So that's derivatives of functions of one variable.